All right, last time we finished off talking about some string trivia. I'm going to blitz through it again. You can use single quotes or double quotes to make your strings, doesn't really matter. But if you really want to use single quotes within your string, like this, see how I'm using the single quotes? You got to use the double quotes. Because if I try to do this, Python's just going to get confused and be like, wait, where's the string, where's not the string? Unless you use this special thing here to signify like, use like the single quotes. So that slash makes it like, you'll see the slash isn't printed out. That's because the slash usually signifies something special. In fact, if I go over here and just write a single slash, well, it's getting confused because it thinks that slash is a part of the quote, like it belongs with the quote. But if I do this, okay, so it comes out alone. Long story short, you just got to pay attention. Make sure everything checks out. If you run it and you're like, wait, why is it so confused about my strings? And you're using quotes in there, just have a look. We can concatenate strings, we know that. We can make strings repeat by multiplying it. We can convert strings to ints and vice versa. Strings can exist but be empty, but they're still strings, which is interesting. And we see some special characters. Well, we saw the slash quote. Oh, by the way, also if you're saying, well, what if we want the double quotes in our string? Like, what if I want to do something like this? Well, take a wild guess. There we go. Do note that in many other popular programming languages, strings are all double quotes. You're not allowed to use the single quotes for strings. Because single quotes mean character. And you can only ever have one character. So FYI, a little bit of string trivia. Slash n, make a new line. Slash t, make a tab. Great. Also, weirdly, I can ask, I print out A, right? What if I ask this? I said ORed. That's just a fancy way of saying, give me like the number representation for the number, or pardon me, the letter lowercase a, which is of course different from uppercase A. Also, I can ask for the byte. How do I do this? I forget. Let's remember. Get a byte from or Python. Let's see if I can figure this one out. Oh, I guess it's saying maybe they're not. Well, that's okay. What is 97 in binary? Let's try this. Look at that. I just told, this isn't really related to strings yet. I just told Python, hey, make a variable called a and have the binary number, that's what the 0b means, have the binary number 11000001. Right? And when I tell the computer to print it out, well, it just prints it out as an integer because that's, why would you want to see the binary, right? I wonder if I can do like bin of a. Well, now, there we go. There we go. In fact, I'm willing to bet if I go back to what I was trying to do before, print bin of A. What if I do order? So what I've told the computer to do, this is what I was trying to do a moment ago, is take A, which is the character A, and convert it to like its number representation. Right? And then convert it to its binary representation. So I just changed some operations together. So we see that A, the character A, is represented by 11000001. I can cut out this variable here. Let's simplify this quite a bit. There. Right? So this is saying, take the letter A, but tell me what its binary representation is. So this right here is A. And then, if I do like print the char of, or I guess stir, of 0B1100001, I don't know what's going to happen. Look at that. Why string 97? I wonder. How do you do char? CHR. Well, look at that. If I say, give me the binary version of the character A, okay, well, it's that. And then if I say, well, take that exact same thing, the binary number 11000001, but tell me what it is as a character, it says, well, that's the character A. That's the letter A. If I go here and say, you know what? Interpret that as an int. It's 97. So what the binary encoding, what those zeros and ones mean, depend on how we want to decode them. If I decode 11000001 as a character, I get A. But if I decode that same binary sequences, that same series of high voltages and low voltages, if I decode that as an integer, it's 97. So it's kind of neat how, like, 11000001 is kind of playing double duty, right? It can mean many things, it just depends on how I decode it. It depends on the type that I care about. Any questions about this? Raise your hand if you're like, well, that's okay, but that's kind of weird, right? Yeah, it's kind of weird. Raise your hand if you're like, yeah, whatever, all right, fine, sure. Yeah, a little bit of whatever. Raise your hand if you're like, I don't care. Yeah, okay. Now, I wonder what happens if I do like +1 here. Well, I got 98, which is interesting. Because I added the decimal number 1. I mean, which would be the same as like 0B. Whoop. Right, there we go. Now the real test time. All right, are you ready for this? Here's the real test. What letter would we expect to be printed out if I do 11000001 plus 1? Raise your hand if you're bold enough to guess. This isn't a trick question. On the count of 3, yell it out if you know. 1, 2, 3. B. Let's see if you're right. Oh my gosh. What happens if I do 2? On the count of 3. 1, 2, 3. C. Of course. It's kind of neat. Who wants to know what -1 is? What comes before lowercase a? Ooh. Oh, I guess it's that little Funny little symbol. That's over your like tab button on your computer. I wonder what -2 is. Underscore, -3. Little like hat, caret, or whatever. In fact, if we go back here, look. What comes before A? It's that funny little thing. Then we've got underscore, then we've got up. I bet you if I do -4, we'll get that bracket. There we go. Cool, right? Any questions about any of that? All right, well, that was a bit of a tangent, but that's okay. Okay, so I'm going to show you a little bit about formatting strings. I'm going to go quickly through this. The point of what I'm showing you is that you know that this little description exists, these ideas exist, and then if and when you want to do it, you go back and have a look. It's pretty easy. But I'm going to go a little quick. Also note that there is arguably a much nicer, cleaner way of doing this in Python, what I'm about to show you. But I'm showing you this way because many programming languages would do it this way still. So Python does it this way, but they also do it perhaps a better way, but we're going to learn this way because it's more universal. So, this is %.2f. This is an example of one of the things we can do. So f is for float. If we're on the right-hand side of the dot, that represents how many decimal places I want. So, if I say .2, that means 2 decimal places. So you will see in that example, I have print format to 2 decimal places, :space, %.2f. Then space, notice that there's no comma there. Space, then I have %a, where a is the variable there. The percent symbols are very important here. They're kind of like the flags to the computer to be like, oh, this matches with, I replaced that with that. And if we hit run, we will see this, 1.24. In fact, notice that it rounded for us. That's pretty cool, right? So if we do that, it'll format our output string to, oh, I guess I shouldn't have had the comment on that line, but whatever. Formatted the output string to 2 decimals. What if I had 2 values? What if I had A and B, and I want to print them both out? Well, same idea, but let's say I'm doing A, I want 2 decimal places, and then with B, I want 4. Why? Because these are arbitrary values, I'm just playing around. Then you do the percent, but do note that if you ever have more than one value in a string that you want to be there, you need to put it in these parentheses. You need to make it a tuple. Why? Because. So, A, B, you'll notice that A will be formatted to 2, like before, and then B is formatted to 4. 1, 2, 3, 4. I guess it rounds up to 4000. It keeps the zeros for us, which is handy, right? Because maybe that 0 is important for a placeholder. Imagine you had like $5.90. If you just printed that out, Python's probably going to say 5.9. But you know, it's cents, so really it should be 5.90. So you might be able to do like .2f to always have those 2 decimal places. Is that a question or just scratching? What's up?
Why is the %.2f within the commas and doesn't show up?
Within the comma?
Like when you're writing like the first function, the format 2 decimal places, the sentence shows up. And the %2f is within the commas, but outside.
Oh, you mean the quotes within the quotes?
Yeah.
So that's just a symbol to say like, okay, I'm going to replace this %.2f with whatever value A has. So it's just basically a tag for the computer to be like, oh, okay, so they're going to give me the percent saying like, okay, they're going to give me something here. Oh, the F, oh, it's going to be a float. They want 2 decimal places. It's just a whole bunch of symbols that won't get printed out because it gets replaced with the formatted, based on what those symbols are, the formatted value of, in this case, A. Okay. And if you're still wondering, but why? Because some engineer somewhere made this the rule and then everyone went with it. Do you have a follow-up?
So it needs to be within the
quotations. Yep.
Outside the colon, after the colon.
Outside. No, that colon, that's just because I wanted a colon there. It does, there does not necessarily need to be a colon. The colon is because I wanted to print out the colon.
Okay.
Like, let me do a quick example. I'm going to take this code. Don't need this. There. You might say, but why on earth would you do this? You probably won't. But that's how it works. Because I say format, blah, 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 space, percent, da, da, da. But notice that immediately after the F, it carries on. It turns into the A. So it doesn't really matter. It's just that's like the symbols that we use. And if you're saying, how on earth am I going to remember this? Don't worry. Just go back here when you need to do it. That's what I do. I never remember how to do this. If you put information on the left-hand side of the dot, that means how long will that string be allowed to be in total, including even decimals. So in this example, I say 5. That means everything that I'm printing out will be 5 characters long. And I want 3 decimal places. Oh, let's go back up here. 5 and 1. So we see 1, 2, 3, 4, 5. And that extra space there, that's this space right here. So it pads it for us. Here's it with 2. 1, 2, 3, 4, 5. That extra space. 1, 2, 3, 4, 5, and that extra space. Cool, right? Yeah.
Why does it say for that bottom one, it says 5 and 5 chars, but then the output says 4 to 5?
Oh, because I typed it wrong. Here, let's fix that. Ah, don't look. I accidentally just had the solution to assignment 2 up. Oh no, you can pause it on the recording. No. Don't do that. I might have to edit the video where I get rid of that. And if we, come on. Still not updated? What's going on here? It's being slow. Well, whatever. Good eye. We can left justify things. What if you want the value to start kind of like growing from the left-hand side? Just kind of like left justify in Microsoft Word. Let's see, did it update yet? There we go. Look, it's fixed already. You can put the negative to mean left justify. Let's justify the number and then neato. So I've got 10 characters, 2F, but it's left justified, so it pads growing from the left to the right. You could do multiple justifies in the same thing. I want 10 characters left justified as a string, so S is for string, I guess, and F is for float. And then here I want 10 characters, but not left justified, just regular. So what do we have? Total. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then starting from there, 1, 2, 3, 4, 5, 6, 7, 8, 9. I probably miscounted, but whatever. There's 10 and 10. Okay, so now a little bit about objects. You've been using them already. If you ever said like some variable that's holding a string, let's say it's A, and then you press dot, period. I'll show you what I mean. A whole bunch of things pop up. Who here's seen something like this happen on Colab, where this little box shows up? This is showing the methods that you have available to you. Now, when I say method, method is just a fancy word for function, okay? As far as we know at this stage, method's just a fancy word for function. But methods are functions that belong to objects. So, you're scratching your head going, what? I know. Well, a lot of people kind of agree with you right now. But let's just go with it. If I say A, oh, I guess A still thinks it's a string, so it's giving me integer things. I don't know, what's going on here? Okay, A dot, look at that. Count, encode, look at this. Look, when I use the arrows, it's even telling me over here the description of what that little method is doing. That's pretty cool. I wonder what happens if I do like A dot capitalize. Look at that. What did it do? It added a capital. It made the H an uppercase H. Cool. I wonder if there's like an uppercase. Upper. Who knows? What's going to happen? Ah, there we go. There's a whole bunch of these methods that belong to strings. Now, you might be wondering, why am I not writing this? Okay? Why am I doing A dot upper versus upper of A? Right? Because remember, with print, it's print A, not A dot print. So what's going on here? Why is there like a completely different system of formatting and writing your code in this particular situation? In a couple of weeks, you're going to be happy with this. You're going to be very happy with this. In the time being, you're going to be left going, what? Why? And the problem is, unfortunately, there's no perfect linear pathway of learning programming. There's no, well, first we start here, and then from that we learn that, and then that we learn that, and then that we learn that. We've been doing that so far. But we're starting to get to points where it's like, okay, we learn this, but that's not going to make sense until we learn this, but we can't learn that until we learn this. And then we have to go back and learn that, and then that we can learn that, and then that will make that make sense. It starts getting crazy. So we're starting to get to some points where, just go with me. I'm going to explain a little bit more still. Hopefully it's not too bad by the end of this. But be warned that it will be a little weird for a little bit. So, the reason is because A.upper belongs to that object. And strings are what we call objects. Now I need to put an asterisk next to this because Python is a little different. But I'm going to be talking in a conventional object-oriented programming paradigm style. So what I'm about to say is kind of true in general, but there's a lot of asterisks in Python. And another thing to remember too, going back to my thing about the learning, like first we learn that, then we learn that, then we learn that, and it starts to get all over the place. For better or worse, you got to remember, Python wasn't made by engineers for people to learn how to program. Python was made by engineers for engineers that knew what they wanted to do as engineers. So, they kind of got to a point and they made this thing for themselves. And then you're starting over here. We're getting you there. We're getting you there. But we got to get there first. So I know there's going to be some wait, what? And I'm going to try my best to make them as painless as possible. Anyways, so we have what we would call, classically speaking, primitive types. Those are things like integers, floats, booleans, in other programming languages, individual characters. And we like these because, the computer's broken down into RAM, right? And there's chunks of RAM that store bits and bytes and stuff, right? And if I'm storing an int, we saw that I represent that as that binary encoding. And if I decode it as an int, great. I know it's 97. 110001 was 97, right? And if I decode that, as an int, it's 97. And I know how much room integers take up. I know how many zeros and ones that I'm going to allow in all my integers on my computer. So I know how much space in memory integers are going to take up. Why did they even have markers in here? we like to talk about, for teaching purposes, this isn't even good either. Yikes. For teaching purposes, we like to talk about memory as this nice chunk of contiguous chunks of RAM. Basically, there's these like cells where we can store information in there. This is idealized, this is not how it works really, but to get the high level idea at this stage, that's good enough for understanding what's going on. This will do the trick. Let's say I want my computers to be, 32 bits. So, I don't know. Let's say I want to represent all integers with 32 bits. 32 zeros and ones. So maybe each chunk is like 32 or something. So if I have an integer, I can store a single integer right in here. 15, great. It's got 1, 2, 3, 4, 5, 32 of them. And I can stick that nicely in there. Same with a Boolean. A Boolean's great. You can store that with 1 bit. It's either 0 or 1, true or false. Floats, characters, individual characters in other languages. Remember if I had 97, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0. And if I want this to be an integer, well that's, 97. It might be hard to see, but whatever. Down here, if I had 1, 0, 0, 0, 0, 1, 1, a whole bunch of leading zeros to fill up the rest of that chunk of RAM, it might be the character A, right? I know how much room each of those things takes up, right? A character takes up one of these slots. Okay? So let's pretend for a second you're a character. You're the character A. And that row right there represents a specific segment of RAM. You fit perfectly in that seat, don't you? You're very comfortable, aren't you? And you too, you're a character, maybe you're an integer, whatever. And you're sitting there, you're comfortable, nothing going on. In fact, you're kind of leaking over, but let's pretend that's not happening. Just you're using the other table, I'm teasing you. You all fit nicely in your chairs. You fit great. You're all primitive types. You're all integers, characters, whatever, you're happy. But let's talk about strings for a second. What's funny about strings? If a single character fits nicely in one of these seats, I've got a bit of a problem, don't I? If a single character fits here, but I have the string hello, H-E-L-L-O, 5 characters long, do you think I can shove all 5 characters in a single seat? No. I have to get creative. What we would actually kind of do is, well, I could have someone be H and sit in that seat, and then E and then that seat, and so on. And just have them in a contiguous chunk of RAM. And then we've got the string hello. But do you see how hello is, it's just bigger. There's more going on. This is like what we call an object in this object-oriented world. So we don't have enough room in a single seat for a whole string. So strings are a little different. In fact, do you remember how you can index strings? That's cool, right? Well, it's kind of related to that idea. Like, well, the string, but which seat are they in? Which seat is the character I care about? When I talk about lists, which we'll probably start by the end of today, the second half of the list lecture talks a lot more about this idealized situation. Any questions, though, about that weird, funny little concept? We're going to learn a lot more about this as we go. So other things, strings, NumPy arrays, lists, those are objects. And we can even make our own objects. You can define, you can tell the computer, I'm going to make my own object that holds this information. We're going to be doing a lot of that, actually, as we go throughout our computer science degrees. But anyways, methods. Print, that's a built-in function. We got it for free. If I say print hello, it prints out hello. We wrote our own functions too, right? We wrote like char is it. And is A and blah, well, it returns true or false. We wrote those. But we didn't have to put something dot char is it. This activity is saying, go do what I just did. And it gives you a whole bunch of options. These are all methods. These all belong to a single individual object. Or the class of that object, pardon me. It's complicated. More on that, even more in a little bit. I'm throwing you to the deep end right now, but don't worry, all I'm saying is, hey, by the way, this is a thing. Stay tuned. So there's a lot of things. This is saying do what we just did. Basically, methods are functions, but you tell individual objects to do them. Methods can take parameters as well, but sometimes you have to say, the thing dot blah, 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 blah. And sometimes you say, function name, variables, parameters, whatever, close parentheses. If you're thinking, how on earth am I going to remember that? You're not. It just comes through practice. Is this a function or a method? I don't know. How do I find, where do I? Practice, practice, practice. It'll be second nature in no time. And if you're wondering, but why do we write it this way? Because some engineer somewhere wrote it and everyone went with it. It's just the way we do it. If you don't like it, I'm sorry. Go back in time and tell them you don't like it. If you want to do some heavy-duty stuff with strings, there's even a string library too, by the way. Anyways, any last questions about any of that before we move on to lists? Okie dokie. Next. So, I've got good news. You're actually all kind of familiar with lists so far. Not only have we actually been using them without having learned about them formally, but strings are a lot like lists. Anyways, lists. Everything we've seen so far, like integers, characters, floats, booleans, although again, characters don't really exist in Python. But we saw strings and strings were fine. And, well, can we generalize that to not just have a collection of letters, but can we have a collection of whatever we want? Of course we can. Those are lists. We've been using them for weeks. They were in assignment 1, they're in assignment 2, they were in your first lab. So, this right here is called a list. And right here, I'm going to just basically write this code. A equals 5, 4, 3, 2, 1. 0. There you go. Great. Let me ask you, how long is that list? It's really not a trick question. Somebody yell. 5. 1, 2, 3, 4, 5, 6. Oh, who said 5?
We counted, started at 0.
Well, hold on. There are 6 things in there. That's the length. The last index is 5.
If you're trying to reference it, you last one.
Well, who talked about referencing? I asked how long is it? It doesn't. Good. I'm actually really happy that you said 5 if that's your logic. Because, yeah, you're right. 5 is the last index. A at 5 is 0. There's no such thing as A at 6. But, of course, if we ask what's the length of A, it tells us 6. Because there's 6 things in there. Anyways, here's a list. What are the types of things in that list? Who can tell me? Someone yell it out. Come on. It's, again, not a trick question. It's integers. They're just integers. Why? I mean, look at them. They're integers. I wonder what happens if I say, what's the type of A? Oh, it's a list. Great. So Python knows about lists. What's A at location 0? Well, it's an integer. Why? Well, because A, which is the list, at location 0, well, that's 5, and 5's an integer. Great. Anyways. There we go. Oh, yeah, we can do the fancy, slicing here. at location 2 to 4. Oh, not the type of that, my goodness. Great, we can do that too. So, yeah, let's do an activity. We haven't done one yet today. Let's do this. Hack around with lists. Best way to learn this stuff is to just play around with it, see what you can do. Try these couple things, and I encourage you to try to do other things with it. Just see what you can do with it. So what do I say? What are the types are we allowed to put in lists? Can we put different types in the same list? What type does a list have? Well, I spoiled that one for you. How do you select the last 3 items? Oh, well, semi-spoiled that for you. Can we have a list with nothing in it? That's an interesting one too. Anyways, hack around. Take a couple minutes and play around, do these things, and just see what else you can do with lists that's interesting. Let's start answering some of these questions. Can we put different types in the same list? Anyone try that? Did it work? Yeah. What if we do like 4.1, the string 3, true. Oops, I guess I need to, there we go. Of course we can. There we go. Cool. And it's actually kind of interesting that we can put strings in lists, right? Because strings we saw are kind of like lists. In fact, here's something interesting. 0, 1, 2, 3, 4. A at 4 is the string woo. What's A at 4 at 0 though? Raise your hand if you think you know. Really high, I want to see. So here's the thing. There's no trick to this. Just like everything in programming is, what are the rules? Follow the rules. Follow the simple rules. You'll be safe. So, if A at 4 is the string woo, well, what is woo at location 0? Yell it. W. W. Did anyone else discover any other interesting type they can put inside lists? No? Did anyone try this? Let's print out A. What's in location 0, 1, 2, 3, 4, 5? What's in location 5? It's a list. I can put lists inside lists. That's interesting. What types? We'll already do that. Select last 4 items. Can we have an empty list? It's kind of similar to an empty string, right? I can do like B equals open, open, close. There, great. Print B, print type of B, and you know what, let's print the len of B as well. Well, B, there it is, nothing. Its length is 0, but it's a list. So lists can be empty. That's great. Did anyone else try anything interesting and got some funky results with lists? Did anyone try any methods that belong to lists? What do I mean by that? Well, A dot, look at all that. Append. What do you think that's going to do? Let's append 66, and then print out A. Well, there we go. Any questions about that? Like, I just appended something to the list. That's pretty great. Lists are our first example of like a real data structure. And it's funny, lists are remarkably powerful and awesome. Lists, not many programming languages give you lists for free like this. Yeah?
You know, it's not like you can append like an add 66. Could you like remove something that same way?
Oh, let's try. Let's see what happens. A dot, well, there's a remove value. Okay, so it looks like we need to give it a specific value. So let's say we remove true. Oh, what did we do? Oh, because it's print. Looks like it works. Best way to learn this is play around. I'm going to simplify something here. A, B, C, D. There. Is there anything particularly remarkable about this list? No, it's just a list with the letters A, B, C, and D in it. Great. It's a list of length 1, 2, 3, 4. Great. What's its type? List. Nothing particularly remarkable. Who wants me to absolutely blow their mind before we end for the day? Everyone say yes. You can say it with more enthusiasm. Okay. Remember, I can append to a list. Nope, a list dot append. And of course, this is a method, D, E, because whatever. And you know what, let's print it out before and after. So first it was A, B, C, D. Then we appended E, we printed out again, it got an E. Great. Nothing remarkable, right? All right, are you ready?
Yeah.
Are you? I don't know. I don't know if you are. Okay, what's the length of this list after here? Well, 1, 2, 3, 4, 5. Great. Now, I'm going to print a list. So, I'm going to ask you a question. I'm going to ask you a very interesting question right now. Can anyone in here think of anything at all, that I could append to this list that would, like, just blow your mind? Like, what could I possibly append to this list that would be absolutely terrifying? No ideas, eh? Come on, I want to see anyone. What do you think?
Can you append nothing to the list? Just like list like.
No, I guess it's like, well, no, you gotta have something there, I guess. I mean, I could probably do this, but I mean, that just appends an empty string, so. I like what you're thinking, though. Any other ideas? What do you think?
A function?
Actually, we could do that.
Oh,
And that would be weird, right? But we can do that in Python because Python functions can be like type, whatever. Anything else? By the way, those are good guesses. All right. Are you ready? I don't know if you are. What if I do this? Oh, man. If your mind's not blown, slow down. What am I saying? First of all, this can't possibly work, right? Sure it will, right? That's what you say? Wait a minute. We put the list in itself.
why doesn't it just go A B C D E A B C D E?
I think that's what the ... means. This is like,
It just gets too long.
it's just like, you know what? Yeah.
Okay.
Because here's the thing. A at 0 is A. Or not A, I need A list. A list at 0 is A. What's A list at 5? Oh, I guess I need to print it. Oh, wait, I just did. A list at 5 is E, right? I'm going to add another print here just to give us a space. What's A list at 5? I already did it. Oh, well, it's that list. And so what's A list at that 5? Oh, it's just that list, right? And then A list at that 5, and 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 that 5. Who wants to guess what's going to be printed out? You better know the answer. But, well, if you can follow patterns, you'll know the answer. Is that what you thought? Huh. Who here thinks this is weird? Put up your hand. This is absolutely bizarre, right? Now, next class, probably next class, so tomorrow, I will hopefully make this make sense to you. It'll actually probably, if you're paying attention, you'll be like, oh, okay, that does make perfect sense. But at the time being, be mystified by the magicalness of computer science.